1.
Okay, this is part 3 of our formative review. We're starting at number 9 on this segment. It's asking us what type of reaction is elemental magnesium plus silver nitrate, AgNO3, in an aqueous solution yields magnesium nitrate in an aqueous solution plus elemental silver. All right. So as we look at the reaction, we can see that what's happening is magnesium is replacing silver in this compound. Only one element is getting replaced since we're starting off with one element and one compound, and our product is one element and one compound. This is a single replacement reaction. Number 10. This is also asking what type of reaction we've got here. We have potassium chlorate yielding 2 moles of potassium chloride and 3 moles of elemental oxygen. We have one reactant giving us 2 products. That is always a decomposition. Number 11. Two moles of C2H6 plus 7 moles of elemental oxygen yields 4 moles of CO2 plus 6 moles of an unknown substance, but we know that every time we have a hydrocarbon plus oxygen, we have a combustion reaction. And we also know that the products of a combustion reaction are always CO2 and H2O. So that's what we're writing in this blank. Always CO2 and H2O. Number 12. All right. We're asked to find a missing product in number 12. We are given C6H12O6 in an aqueous solution. We are given an enzyme, and then we're shown that it is a balanced equation. We have 2 moles of our product plus 2 moles of CO2 gas. The way we're going to solve this is we're going to balance the equation for our unknown. On our reactant side, we have 6 carbons, 12 hydrogens, and 6 oxygens. On our product side, we have our 2 carbons from CO2, 2 moles of CO2, plus 2 times X carbons. It has to give us 6 because there's no coefficient here. When we do the algebra, X equals 2. That's subtracting 2 from both sides, then dividing 2 by both sides gives us x equals 2. Now let's do the same thing with hydrogen. We don't have any hydrogen in carbon dioxide, so we have our 2 coefficient times x equals 12 hydrogens. That means x equals 6. And the same thing for oxygen. We have 4 oxygens in this 2 moles of CO2 plus 2 times what we've got in that compound. That gives us x is equal to 1. Oh, that should equal 6. X is equal to 1 for oxygen. So when we look at choice A, CH3OH, that's not the correct answer. It doesn't balance. Neither the carbons nor the hydrogens balance. When we look at choice B, CH2OH2, OH4, that doesn't balance either. Neither the carbons nor the oxygens balance. Let's look at choice C. We have CH3, CH2, OH. That gives us 2 carbons, 3, 4, 5, 6 hydrogens, 6 hydrogens, and 1 oxygen. That balances our equation. We'll look at D just for giggles. CH2OH, CH2OH. The carbons balance, but neither the hydrogens nor the oxygens balance. So we know that C is the correct choice. Okay.